All right, let's do part C by using the partial fractions business. I think we're going to use a u substitution here because we have 1 over x, radical 3 minus radical x. So let's go back here and call u to be radical x. To make things easier when we differentiate this, why don't we take the square of this? So u squared equals x. So that the differential of the left-hand side is 2 u du, and then the differential of the right-hand side is dx. Okay, what that means is I go back here, dx is 2 times u times du, x is already u squared, and this is radical 3 minus u. Okay, you could perfectly take the derivative or take the differential at this level that, du equals 1 over 2 radical x dx, but I think this way is much easier. And this time we have a cancellation, so this u is going to cancel this power here. So this integral is written as 2 over u radical 3 minus u. Okay, and then we have a du here. So this is a partial fraction question. So let's try to, let me just get rid of those. We don't need them anymore, right? All I need is this substitution here. So I am going to rewrite this 2 over, let me use a different color. And I'm going to use a partial fraction for this fraction where you have the quadratic in the bottom, okay? So both factors are linear, so I'm going to use a over u plus b over radical 3 minus u. Okay, there we go. I'm going to get the common denominator by multiplying top and the bottom here by radical 3 minus u and just u here. So I get down to the equation 2 equals a times radical 3 minus u plus b times u. So we're going to get simple values. So let's say u equals radical 3 and u equals 0. I'm just getting the zeros of these factors as the simple values. So if u equals radical 3, 2 equals b times radical 3. So that makes b to be 2 over radical 3. Okay? And if u equals 0, then radical 2 equals radical 3a. Okay? Then a equals 2 over radical 3. All right, I can go ahead and place those values back in here. So a and b, all right, I'm going to go ahead and put 2 over, just clean this, 2 over radical 3 and 2 over radical 3, and I don't need this part anymore. Okay. So in the next step, I'm going to do the integration because now I converted this fraction here. I converted this fraction here into the difference or sum of two fractions. There we go. So this integral is equal to du, du, and du. Okay. So I'm going to have just one u substitution here because I need to get rid of the bottom like this. So let's say v equals radical 3 minus u. That means dv equals minus du. Okay, so eventually we have 2 over radical 3 ln u for the first integral plus 2 over maybe minus because we have another minus coming along, right? Minus 2 over radical 3 ln v, which is radical 3 minus u. Okay. I can combine these two ln functions by pulling out ln. by pulling out 2 over radical 3. So that I can write this down as ln of u over radical 3 minus u. And don't forget to add an integrating constant here. Okay. And now I'm going to put the u back. Here we go. U is radical x, radical x. Okay. I think this takes care of part C at this moment. Okay, this is the final output. So this integral is equal to this integral here. Okay. All right, that ends this video and the whole question. If you have any questions, comments, or suggestions, please send those to my way. Thanks for watching. Bye.